So here's our meter showing no draw, no power draw over here. So let's try again, and there the power is okay, it's lit, and it's consuming 0.52 amp, or I think it's around 510 or 520 milliamps over there, set to 10 amp setting. So it's quite a waste, but I love the circuit in charging this type of rechargeable capacitive charging system. Capacitive means it uses capacitor. It has no transformer inside to charge the battery inside, but it has a capacitor and a resistor, so it's a capacitive charger. So when I hook this up to this female socket over here, which is the output of our inverter, like that, see the indicator over there, and if we're going to start the inverter like that, and the flashlight is now charging, you can see there that it's charging. So the flashlight is charging, the inverter is on, and it draws 0.57, just 70 or 60 milliamp draw from our battery to charge this one. So even though it's a waste when we have no load, but it still draws small amount of energy or electricity from our battery if we use it to charge capacitive chargers like this one, like LEDs. So let's try to hook another inverter, and let's see how it charges this capacitive flashlight over here. So it's a thumbs up for me, and it's pretty good inverter. So the second inverter is this one. So this is a more complex inverter following this circuit over here. So it's more complicated and has too many components to assemble and to connect with. So let's hook it up and let's see the difference. Let's remove this inverter. Okay, and put it aside. Let's put this one in. This one, and this goes to the positive, which is in the center top of the transformer, and this one goes to another negative terminal, which comes from the drain of one of the MOSFETs, and it goes right through there. This is more complex, more components. I think it's more efficient though if there's no load. So let's hook the negative rail and fire it up. So let's just first remove this. Let's see how it draws when it has no load. So no connection over there from the output, and just merely the indicator light is lit up, and let's see the consumption. So let's change it to milliamps since it draws smaller amperage. So here it goes. So the inverter is on, and it draws just 74 milliamps over there. So it's a quite efficient inverter using 555 timer, and to our MOSFETs. So it draws only 74, around 74 milliamp without load. But how about if we put that capacitive charger over there? Let's try it again. So hook this. I think it's difficult to hook when you have only one hand in use. So there, it's hooked up. Light indicator over there. And let's fire it up. There. Let's change the setting to amps. 10 amps maximum. Okay, 0. And again. There. There you can see when I turn it on, goes to 5.7 amps. See the difference now. So when this is on, like this one, and that is charging over there, and the amps shoot up to 5.6 amps. Therefore, even though this inverter over here is an efficient one without load, but when you use a capacitive charger like this one over here, it shoots up to 5 amperes or more. So it's a quite waste than the first one, the first candidate of our inverters, homemade inverters. So therefore, the 2 ampere capacity of the transformer will not sustain those high amperage drawn from this capacitive. Just one flashlight over here draws 5 ampere more. So for me, this little guy here is more efficient when you use it to charge capacitive chargers like this flashlight, emergency lights, anything that has no transformer in it and has a capacitive charging circuit on it, like a capacitor or resistor and diodes over inside. So it's up for now, and I'm gonna make more videos on the differences of these homemade inverters and its efficiencies. So for now, it's bye-bye for now, since we are just charging this one. So we're using this little guy over here to charge through this transformer, drawing smaller current than this one. Thanks a lot, and if you like this video, please make a thumbs up and subscribe if you want. Leave a comment, anything you want to ask, and I'll do my best to answer all your questions. So thank you, God bless us all.